All right, here's our second video on simplifying rational expressions. If you remember from the videos we've already been watching, what we are doing is we were factoring everything and then trying to cancel anything that is in the numerator and also in the denominator, separated by multiplication. All right, so s minus t squared, what that means is you just have two of those s minus t's. And of course I hate t's, but I'll just leave it, I guess. S minus t times another s, I hate s's also, s minus t. All right, so that s minus t squared means write two of them out, and we cannot do any further factoring with those s minus t's, so that one's good. Over, now we have to look at this t squared minus s squared. Anytime you guys have two terms separated by subtraction, you really do want to think, is this a difference of squares? Are you squaring anything to get both those terms? Well, t times t is t squared, and s times s is s squared. So this factors into our pattern of t minus s times t plus s. All right, so I'm looking at this problem and it all looks pretty similar, but is any of it exactly the same? And that's what we have to think about. It would be great if we could get some things to cancel here, but an s minus t will only cancel with an s minus t. So I look at this and say, well, that's a t minus s. Isn't that kind of close? So there is a trick that we can do. If you've noticed that, and this works with subtraction, if you have an s minus t and you have a t minus s, you can factor a negative 1 out of this t minus s, and the trick that it does is it switches the order to s minus t. So this t minus s, we do this little factoring trick. We factor out a negative 1, and it lets you switch the order to give you s minus t. So this is now gone. So we're looking at anything. I'm just going to rewrite the problem. I want to make sure this isn't getting confusing. So our new problem is s minus t and s minus t over, now we have a negative 1, we have an s minus t, and we have a t plus s. All right, so now do we see anything on the top that we also see in the bottom? Well, we meant to have that happen. We did that trick so we could have an s minus t on the bottom that would cancel with the top. So we have an s minus t on top. On the bottom we have that negative 1, and then we have a t plus s. And then we look to say, is there anything on the top that we also have on the bottom that we can cancel? Remember, you cannot cancel the t's because they're connected with addition or subtraction to another term. So those are stuck together. They can only be canceled together. So we've canceled everything we can, and this is our final answer.